So, search is dead. Long live retrieval. That's a bit dramatic, Gillian. Why the title? So this reflects some conversations I've had over the last year. Google search is dead. Internet search is dead. Enterprise search is dead. Search has failed us, Gillian. Okay, fair enough, right? Okay, I agree. Some issues. What should we do instead? Have you heard about this RAG thing? RAG? Okay, let's go. Who am I and what do I know? I'm Gillian McCann. I'm an AWS machine learning hero. I'm the CTO and co-founder of a small startup called WorkRed Software. And I've been building conversational assistants and search-based technologies for the last 8 years. And hands and heart, it is one of my favorite technologies because understanding language is hard, but when you can do it right, you can deliver really good experiences. So today, we're not going to talk about AWS architectures to build RAG. We're going to talk about some concepts, and hopefully we can learn a wee bit more about search and how the RAG development process happens. So RAG is all the rage. You could not have missed this. There's a lot of concepts and articles and things out there. So let's quickly distill that down into the core components. Essentially, we have three things: ingestion, retrieval, and generation. And what does that mean? Well, we have large language models that have been pre-trained on a large amount of data up to a certain time. So when you ask a question, what's the summary of the Battle of Hastings, you get a nice answer, and you help the kids with your homework, and you're great. But when you ask the question about what's the work from home policy, or can you summarize the reports from 2024 for me, you're going to get no, or hopefully it doesn't make it up. So RAG, or Retrieval Augmented Generation, is about bringing your information to a model. And how does it do that? Essentially, we have data or documents, and there's an ingestion process where these documents are sort of broken down into smaller chunks or information. They're turned into mathematical vectors, which is an embedding model, and then they're stored. And then when the user asks a question or has a query, the same process happens, and the two are compared. And relevant documents are then returned. And at that point is when a large language model takes that context and generates your answer. So it's all about the R. Hopefully from that diagram you can see that 80 or 90% of the work is before the generation of the answer. If your retrieval is bad, the generation will be bad. Garbage in, garbage out. So quickly go over it. We've got our data, we've got our documents. To make this work, we need to ingest them, we need to process them, we need to index them, and then when we have a query, we look it up. Sounds a wee bit like a search engine, my friends. So in my opinion, and building conversational AI and conversational AI search is hard. Good search is like very hard. And why is that? So let's quickly go through some of the concepts around search. Search is a balance between precision and recall. So what does that mean? Precision and recall are the metrics used to evaluate the effectiveness of a search system. It takes a wee bit to understand it, but high precision means that the system is very successful at returning relevant results and minimizing false positives. And high recall means that the most relevant documents have been returned, reducing the fact that you're missing significant documents. Okay, still quite hard to understand in my mind, have to think about it. Super simple example. If you have 100 documents and 10 are about medical benefits, the user asks a question, 5 documents are returned. If those 5 documents are about medical benefits, that is high precision but low recall because there's another 5 documents in the corpus that hasn't been returned. And the goal of a search is to balance those two things, precision and recall, for your use case. Lexical or keyword search. What's that old saying? don't throw the baby out with the bathwater. To keep it super short, a well-built lexical search can be very powerful. For those who've never built them before, it's usually not just passing in the exact words that the user has entered. There's a whole range of NLP techniques that are happening under the covers. There's stemming and stop word removal and use of synonyms. And ultimately, lexical search is about precision. And it favours precision because when you're looking up specific terms like product codes or engineering parts or specific scientific terminology, it is really useful to use a lexical search. And it's also computationally faster and cheaper to ingest than, say, something like semantic search. And semantic search is a big piece of the RAG architecture, but it's about understanding the meaning and intent of what the user is saying. And really this is done by turning words and sentences into mathematical vectors, and an embedding model is used to do that. It's super high level in my mind. Really, words become numbers and maths is applied to find the similarity. Now, semantic search is not new, but in the last few years, with the addition of, like we've heard, the RAG pattern being used a lot, and the large models with the pay-as-you-go API has really surged this area. Now, embedding models themselves are evolving as well because there's lots of new models and lots of new dimensions being. It's an active area of research. Like a key part of any RAG architecture is obviously the ability to store vectors. And there's a whole new range of products and services. You know, we have vector DBs, vector engines, we have SQL and NoSQL databases who are offering vector storage. And of course, we have search engines. So what's the difference? Well, this diagram, I think, really helps represent the differences with the search engine. And the ones in red are the ones I want to call out particularly. So out of the box, pre-built ingestion tools and connectors, so that when data is ingested, say from a SharePoint, it understands the content and the permission models already. It's able to keep that information up to date. And it's able to, when the user asks a query, to keep applying the permission model. And I do think when we talk about RAG, that this is an often overlooked area in complexity, which search engines have already solved for us. And also search engines, it's not just about a text or a similarity search. They offer things like dates and times and numeric fields and locations and IP fields so that you can have a much more complex search query that delivers things like filtering or faceted searches or aggregations. And what are those exactly? Because consider this, it's not just finding the needle in the haystack, or as I like to semantically say, a sharp sewing device in the haystack. It's a wee nerd joke for you. So what do I mean by that? Well, how do you answer questions like this? How many needles are in the haystack? What's the average length of the needle? What is the median length of the needle broken down by manufacturer? And how many needles were added to the haystack in the last 6 months? Really knowing your users and your use case will help because there's many different types of queries. There's many different types of searches and ways to index data. But ultimately, lots of these questions cannot be answered with semantic search. I'm sure everybody here has complained about the search at work. But maybe we should consider this. The problem with enterprise search is the enterprise. That's a bit of a bold statement, but it's just a way of saying that it's not always or just a tech problem. Who ensures quality of content, the relevance and freshness of information? Who ensures that data or documents are classified and permissioned correctly? These things all need to be considered because, again, garbage in, garbage out. And search itself is a data-driven technology. So ensuring that it's not just turned on and left, and there's tuning efforts and incorporating user feedback. To not do that with search is a mistake. And I think expectations, or maybe unrealistic expectations, and managing those are very important, because as you start to hear more about AI and AI search, there's one thing that I always like to say: AI is not magic. So search in AWS, what's our options? Let's quickly look at them. So Amazon Kendra, supercharged, intelligent, machine learning-led enterprise search engine. And it was launched in 2019. And I know this because I spoke about it at reInvent. But it offers over 40 plus connectors. It has, under the covers, a lot of ML capabilities. It's using semantic search, it's using keyword search. It has ranking algorithms. Very powerful. But cha-ching, it is very expensive in my mind. And for small and medium use cases, it can be expensive. But recently they have added a Retrieve API, which is essentially where you are using the power of Kendra, and it allows you then to access the chunks of documents you can then use in a RAG architecture. But then there's a new contender. It's kind of a mixed bag, if you ask me. It's two services together. So the Bedrock knowledge base with an open search serverless engine. And it started out with like a basic RAG capability, but the reason I'm bringing it together as a search option is it's added things like filtering and faceted search. It's added connectors recently. There's 5 in preview. It offers hybrid search. So it's offering quite a lot of capabilities. And it will be interesting to see how far it goes, offering opinionated configurations on top of open search service. And then there's the big dog, managed open search service. This is my favorite service in AWS. So even in our serverless architecture, this is the one that costs the money, and this is the one that is such a super powerful engine. It has machine learning ingestion, it has ingestion pipeline search configuration. It's very, very useful, but again, it comes at a cost. So where do we start with RAG? What is that? And in my opinion, most of the basic RAG diagrams are missing one box, and that box is evaluation. And it's critical to gain confidence that your systems are good enough for your end user needs. So how does evaluation fit into a development cycle? And this image represents what's in my head, and we've changed it about 3 times within my team. And it's a big part of building a RAG product, is experimentation and evaluation. And how do you take those learnings through to your architecture of your deployed product? But honestly, it all starts with discovery. Discover the goal. Discovery is all about information gathering to help you make the best technical choices. And if an existing product or capability exists, you need to learn from the usage patterns of that and the problems you're trying to solve. And also, what's the expected benefit? You're trying to save a certain number of hours a week, you're trying to improve the employee experience, you're trying to build better reports, or make customer service faster. And importantly, what's the risk appetite of a generated answer being useful, but not precise? Everyone has access to ChatGPT and Claude and a ton of AI tools, so setting expectations is key, because expectations around AI products are very high. And when someone says, I want to chat to all my internal documents, or I want you to replace enterprise search, I would be very cautious. So discover your users and their goals. So this is important. Discover where the answers and information is going to come from. Is it War and Peace, or is it an engineering manual about parts? Is it a scanned form, or is it a Word document? Is it a common topic like HR, or is it very specific scientific specifications? Is it 200, or 200 million documents. And scale is important because adding more information may seem like adding more intelligence, but if you're thinking about searching for a needle in a haystack, what you're doing is essentially adding more hay. So you have to work your way through that. And discovering as much as you can upfront is so important to success because it enables how much work you're going to have to do in this pre-processing and chunking phases. And importantly, does your data exist with a permission model that you're going to have to replicate? Discover the users and their queries. Words matter. And in some ways, English is both the simplest and yet hardest programming language to build with. And what do I mean? So questions like, when are we paid? Who's the CTO of our good software? Are very different from statements like, compare and contrast the XYZ from 2024, summarize ABC about our company work from home policy. But when you start saying, oh, you can chat to your data, you can chat to your documents, people's perception of that is different. So that's why really understanding the query types, the questions versus instructions will really help determine how to retrieve that information from your databases or your search engines. I'll say it again. I keep clicking the wrong thing. Set expectations of what it can and importantly can't do. The hype around AI at the moment and LLM and RAG is immense, but be realistic with your development team, with your stakeholders, and constantly reiterate that as you learn and build. So how do you experiment? You got to work out how to develop a lightweight experimentation process. And this is key in my mind to making the implementation choices. And there's tons of resources out there, papers and blogs and things like that. And it really is easy to get started with the 50 lines of code. But that's to learn about the concepts. A key part of the experimentation is going to be working through exploratory data analysis and trying to find the information about what's the type of data you're trying to parse, but also using a range of tools. So this is some things that we use in our team. So Jupyter Notebooks, you can use those locally or with SageMaker Studio. And we use a range of APIs and local models. The thing here I would say is we try to keep it as cheap as possible in this experimentation phase. So be cost aware. I do think for RAG, Llama Index is a great resource to start learning techniques. So how do you build confidence? You got to work out which metrics matter to your use case. There's a range of data sets out there that you can explore. You can create synthetic data. You can use industry standard data sets. You can look at existing search or chatbot logs. But ultimately, what you're trying to do is create a baseline set of documents and queries that you can use to continuously assess your architecture and your product. And I've just listed some of these here of the types of evaluations that are sort of being evolved. There's a lot of work in this space. And again, it's about learning what those are and how they apply to your use case. Because you're going to need to measure the quality of your answer some way. And the technologies in this space are also emerging, and we see techniques where we're using large language models to judge the quality of the answer themselves, or use self-reflection. As a guy on our team has said, you're marking your own homework here, Gillian. It feels like that sometimes. So how do you get it into the hands of users? Once you've gone from the pesky notebooks into a deployed environment, a deployed architecture and product, getting real people to use this as soon as possible is key. And that can mean development, user acceptance testing, even in production. It's exploratory testing, it's end user testing, because even though people have said, oh, we're going to ask these types of questions, they immediately bomb in and say something completely different. And you're like, is that usual? Have we got this wrong? So getting people chatting and asking questions is key. But I do think there is an area here that we need to work through, is how do you have this observability in a production environment while maintaining privacy? But you do need a way to understand if all this work that you've put in is actually producing good answers and good experiences in production with the end user? Is it good enough? So what if it's not good enough? What if you've done the evaluation, you've got something out the door, and you're like, people are complaining, or these evaluations aren't very good quality? What do you do? So ultimately, in my mind, this is what a fuller picture of what a RAG, all the different concepts that you could think about when you are looking at a RAG architecture. And the two components here I'm going to call out are pre-retrieval and post-retrieval. And super simply, it's about how do you improve the structure of queries that are made. Basically, how do you improve on the searches that you're going to make? And then how can you improve on the results that are returned? Now, you don't have to do all these. It's like, understand what these are. And this, in my mind, is what I think about. You know, as a builder of RAG and AI systems, that's how I feel. There's like levers, there's knobs, there's things you can do. And half the battle is knowing that they exist in the first place and when to apply them. Cascading decision impacts. Hopefully this sort of shows that there's some decisions, if you can make them early on, they have much more impactful in the development cycle than others. And obviously the earlier you can make some of these core decisions, the more beneficial it will be to emphasize, you know, the importance of discovery. Because if you can discover some of the things that make these choices early on, you know, you're setting yourself up for success. But the reality is, though, this is an iterative process. So new document types might get added, new domains might be asked for, or, you know, you're having a really successful rollout and now they want to expand it. You have to rethink things. So potentially you're going to need an automatic mechanism to re-ingest, re-parse, and chunk everything. But you want to do that in the deployed environment without the user knowing. Also, being able to run A/B testing with different configurations can be really useful. So how can we improve? Ingestion. Just some ideas here. We're not going through them all. But what if, for example, if you needed to, you were getting questions like, what is the X from 2024 written by Gillian? Find all the information we have on Y. What is the bonus payment in the UK versus the US? What if you use metadata extraction, which is essentially about pulling out a range of different information as you're ingesting and processing the information. So pulling out important entities that can be used for further searching and filtering, like author, last updated date, topics. Another area to consider is maybe the generation of additional information. Like what if you're building an FAQ style chatbot? Maybe it would be more relevant to search for similar questions than the chunk of data that contained the answers. So there's a thing you would generate hypothetical questions, and that has proved quite successful. The embeddings. So what embedding model do you use? There's a wide range out there. I would look at the Hugging Face leaderboard. You can see a range of embedding models there. And also, do you want to host one or do you want to use an API? So quickly to go through our options, like Bedrock has pay-as-you-go models with Titan and Cohera through Bedrock. You can host your own in SageMaker, inference endpoints or service inference endpoints, and obviously you can use something like OpenAI. But also you can fine-tune your embedding model. And why would you do that? A large pre-trained embedding model understands the world, but does it understand your world and your language? So potentially there's lots of benefits you could get from a fine-tuned embedding model, but it really needs to be carefully balanced with the added complexity and cost of hosting your own model. You do not start here. Pre-retrieval. How could we quickly change the data that is actually being sent in? How can you change the user query to improve the search results? So some ideas here are you could inject memory to allow for more conversational search. You could add synonyms to expand the query. You could add or change the language. Or you could break down a really complex statement into multiple questions, which is ultimately multiple searches. You're not searching based on what has been entered, but a combination of user-entered and large language model-derived terms. You could consider agentic RAG. And honestly, it's a whole other talk, but if you read about RAG right now, classic RAG is failing, traditional RAG is failing, legacy RAG is like, what? Sorry, was that not new 6 months ago? But anyway, super simple. It is a bit of a buzz at the moment. But without going into agents, it's really about adding a small layer of large language model reasoning and tool selection that ultimately could help you narrow down the amount of documents and indexes and locations that you could search. It could be useful for dynamic creation of search queries and different types of searches against different indexes. As I say, the goal is literally to just reduce the amount of information that's being returned. There's no point looking for the IT help desk manual in the HR documents. And a lot of the problems you see with classic RAG really is about scale and multi-domain and multi-types of documents. Agentic RAG may simplify things, but again, it is for another day. So retrieval. How could you improve retrieval? Hybrid search. Let's go back to precision and recall. This is a technique that is emerging. It is essentially trying to bring the best of both together. And a search engine offers hybrid search is a way to normalize the two scores that come out, the relevance score and the similarity score. So we're seeing more engines offer this. How could you improve post-retrieval? We've done the searches, we've got a lot of information back. Is there anything else we could do there before we send it to a large language model for answer generation? So retrieve and re-rank. Retrieve and re-rank is a technique that's not new either. It's used by a lot of search applications today. Essentially, re-ranking results is using a more precise and accurate model as it contains or considers both the query and the answer in the calculation of its scores. But computationally, it's much, much slower than a search. So essentially, the pattern is you search to reduce down the options maybe to a couple of hundred, and then you pass those 100 into a re-ranking model. And those available in AWS today, it's quite limited. You would have to host your own model in SageMaker. They recently did announce a Jumpstart, Cohere, Nimble re-rank, which is, they have an API that's very powerful, but to begin, cost of some of this is quite expensive. And interesting enough, I haven't tried this yet, I noticed that Kendra has an intelligent ranking API that potentially is the pay-as-you-go ranking option that I've been looking for. And re-ranking can be really helpful when you have multiple sources and large data sets that you need to narrow down further. And just because it's worth saying twice, working out an evaluation mechanism from development to end user is key. And I don't mean the development team sitting around looking at documents going, oh, I can answer this question. I'm saying that looking at my development team, because we do that, but you got to have more, you got to have rigor to this, because language and the words that people use in production with conversation assistants will surprise you. So is search dead? Absolutely not. Search is not dead. Search is evolving and emerging and converging with conversational AI to deliver really engaging experiences. AI is not magic, but it can deliver magical experiences. And thanks for listening, everybody. And hope you enjoyed this super whirlwind tour of search and RAG and things you might consider to build a RAG-oriented product.